if you are struggling with your Beers Law lab write-up, this will hopefully help you because I'm going to do some example work for you. So as a big overall picture, remember that you can use light traveling through a solution to tell you something about how concentrated it is. Like if you shine a flashlight through a really concentrated, like dark red Kool-Aid, not much light is going to get through. And so you can actually measure that and figure out an unknown concentration after setting up a standard curve. So what we did in this lab was we collected data for known concentrations. Okay, so I'm going to skip down here because let's pretend you already did the part where you calculated how to make each solution. Okay, because we did that part in class. But let's say you measured the absorbance. These numbers won't match yours, that's fine. You measured the absorbance of the concentration of yellow dye, and this is 0.000065 molar, but just to be short, we're writing it as 6.5, and then the times 10 to the minus fifth is up there. So as it gets less concentrated, notice less light was absorbed. So this data makes sense here. The numbers are dropping down. Okay? I also took the data points for yellow Gatorade and Mountain Dew. Gatorade was 0.793. Mountain Dew was 0.492. So even just visually, you can kind of see 0.793 is fairly close to a concentration of yellow dye of 0.000065. Okay, we're going to figure it out a little more exact. It's a little less concentrated than that since that number is a little bit less. And you can see where the Mountain Dew fits in too, somewhere between the 3 times 10 to the minus fifth and 4.5 times 10 to the minus fifth. Okay, so what you were supposed to do is graph your data. So here I graphed my data points, and make sure that you've got your units labeled, you've got a good title. Okay, then you're going to pick 2 points on your line and calculate the slope. So I picked the points, and don't forget the times 10 to the minus fifth. Okay, it says it right there. I picked the points 6.5 times 10 to the minus fifth, comma, 0.8, because that was right on my best fit line. And I picked the point 1.5 times 10 to the minus fifth, comma, 0.2. So now, in order to calculate slope, I'm going to do the change in y over the change in x. So that's 0.2 minus 0.8 divided by 1.5 times 10 to the minus fifth minus 6.5 times 10 to the minus fifth. So you're going to do this with your data. And for me, I get a slope of 12,000. Notice also they don't have to be your data points. Mine happen to work out, but yours may not be. That's fine. Okay, so my slope is 12,000. Now I'm going to go down here. The absorbance of yellow Gatorade that I got, let me write out this formula real quick, was 0.793. That's from my data. So you got to go back and look at your data table up here. What was your absorbance for yellow Gatorade? Okay, so mine was 0.793. Now, I'm going to put in the slope that I calculated, 12,000. So this formula, Beer's Law, tells us that the absorbance is equal to the slope of the best fit line from the standard curve multiplied by the actual concentration. So how do I get concentration by itself? I've got to divide both sides by 12,000. So 0.793 divided by 12,000, for me that comes out to be 6.6 times 10 to the minus fifth, capital M. So based on what I said earlier, it was supposed to be slightly less than 6.5, so I may not have drawn the best fit line, but that's okay. All right, I'm not going to do it for Mountain Dew because you follow the same steps for your own numbers anyways. Okay. You calculated the concentration of your unknowns using Beer's law. You can also visually estimate this. Mark the absorption value of each unknown on the line. Then draw a dashed line down to the x-axis. Record the value where the dashed line meets the x-axis. So I'm going to do this for yellow Gatorade as an example. Okay, so I'm going to go up and yellow Gatorade, I already mapped this on here, the 0.793, so the star goes here, so I'm going to draw a dotted line down, 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 down. I'm going to estimate that as 6.2 times 10 to the minus fifth. Okay, so I'm going to go down. My visual estimate here was 6.2 times 10 to the minus fifth. Is that pretty close to 6.6? Did your values match up fairly closely? I don't know. It's hard to gauge without looking at more data. Fairly close, I'm going to say. Okay, so you need to do the same for the Mountain Dew as well. Okay, discuss 2 sources of error in the lab. You guys can do that. Think about things that may have caused you to have inaccurate data or maybe assumptions that you made. Like one assumption I can think of is that we're making the assumption that yellow dye number 5 is the only thing that is added to the Mountain Dew or Gatorade to change its color. And then the last question here talks about lethal dose. It says the lethal dose for yellow 5 is 12.8 grams per kilogram. So for a 60 kilogram person, how many bottles of Gatorade can they drink before it becomes lethal? Well, first step, we need to figure out how many grams of yellow dye is that. So multiply the lethal dose by the weight of the person. They would have to have 768 grams of tartrazine. That's the chemical name for yellow 5. How many moles is that? Well, 1 mole is 534.36 grams. So divide by the molar mass, I get 1.44 moles of the tartrazine. So then you need to take a look at the concentration that you calculated for the yellow dye. Like for me, I calculated that it was 6.6 times 10 to the minus fifth. Yours is going to be different here. The bottle was 0.946 liters. So multiply to figure out how many moles of yellow dye are in one bottle. So if 1.44 moles kills you, and there are 0.0000624 moles in one bottle, you would have to drink 23,077 bottles. So you'd have to drink quite a bit of Gatorade in order for the yellow dye 5 to kill you. All right.